We're going to start off with just some basics on why do we want to be involved in consulting with producers on managed grazing? What's the goals and why do we want to do that? So what we'll be covering today in this topic will be what is managed grazing, what are the benefits of managed grazing, and we'll go through the economics, enhanced quality of life, the better environment, and improved animal health and nutrition. Those are really the three principal things that we can really say are going to be the benefits of somebody implementing managed grazing on their farm. You know, there's always people that I've worked with in the last 25 years that we call them naysayers. They have a reason that they don't want to try grazing at all, and that's fine. It's not for everybody. There are those people who prefer to grow annual crops or row crops, and that's fine too. But some of the quotes that we get from naysayers there's always a good answer to some of them. And it may not be logical to them, but we have some answers, such as the one where we tried rotational grazing years ago, but it was unproductive and didn't work. Well, maybe the basic tenets of grassland growth, of grass growth and grass physiology, they didn't know. And maybe they did it on a calendar basis. They rotated the animals every 3 or 4 days according to the calendar. So maybe some of the techniques that we use today didn't have available to them. And then the other one is I must graze my livestock to be certified organic. What is the minimum I must do? Well, if they're asking you for the minimum and to become organic, then probably their whole heart isn't into grazing. It's getting the higher premium for the higher quality product or higher valued product. Usually I like to see people go to be a grassland farmer first and then to become certified organic after that. It's always easier to get the concepts of the management of the grasses down before you become certified organic. Another one is, why would I want to lower my animal production by grazing? Well, as we know, for years, production was always the key. It was always a goal we strove for. But really, as we get smarter in agriculture, it's the bottom line that we're looking for. So yes, if you do lower your animal production goals, especially maybe in a dairy, maybe your milk production per cow might go down, but your costs go down dramatically more than your milk production goes down, then your bottom line would go up. So it's not all about animal production or crop production, it's about bottom line. The other one is we can't bring animals on this farm. We have no facilities. We're not livestock farmers and we don't have time for animals. And that's a good one. That's a hard one to argue against. So if they are all set up for crops and don't have any interest in livestock, that's fine. Maybe if they put cover crops on, they want to graze, maybe they can bring animals over and lease them for a time, or maybe not have to have any livestock facilities. And my favorite one is the last one. This land is too valuable to convert to pasture. Well, that is unproductive pasture. But if they want to convert it to pasture and do the management that's required of it to become productive pasture, that no land is too valuable, because it's the bottom line in dollars per acre. So let's start with some definitions. What is managed grazing? And I like to emphasize that it's a goal-oriented approach to grassland management. So it's a goal-oriented approach to grassland management where the land and animals are managed for optimum production and environmental protection. So when we're looking for optimum production and environmental protection, we're probably going to be talking about some kind of a rest rotation system. And so examples of rest rotation systems, because of the fact that grazing all season long on one particular pasture is really going to be hard for the animals. So they will be hard for the animals and hard for the land. So we want to have a rest rotation system of some kind to be called managed grazing. So pastures divided into paddocks. Some are grazed while the remainder rest. Occupancy period of 3 days to 1 week is a rotational grazing system. If we're the more and more intensive we go, as far as occupational periods, the different name we give it. So management intensive grazing, which emphasizes greater numbers of pasture subdivisions or paddocks, where you have an occupancy period ranging from half a day to 3 days. And then we go further down the line into a system where we're doing land reclamation, we're doing a mob stocking or very, very high density rest rotation grazing, where we have occupancy ranges from maybe 3 to 6 hours. This is something that is very specific, that helps to revitalize all the stands, improves production, and is only really done with certain kinds of livestock. So what grazing system is best? Well, what expectations do you have for production? And these are some of the questions we might ask. If you have a very high expectation, then you need high management. And what is best for the soil and the forage? If you have a certain kind of a forage that you need to grow, seasonal forage production, such as an annual, well, you would design that system for grazing at the time when that annual is in peak production. The same thing with the soils. What's best for the soil? If you have a very dry soil, you may need longer rest periods than a very high fertility, high water holding capacity soil. What's best for the animals? Milking animals need higher quality pastures, need higher quality forages than, say, dry animals or non-milking animals. Cow-calf systems maybe need a different forage quality than a finishing of a steer on pasture. So the higher the management, usually the better the production and better the outcomes, not necessarily the production, but better the bottom line. What are the benefits to adopting managed grazing? Well, certainly farm profitability. We'll see some examples here in a minute. Quality of life. We actually have these documented through some research the University of Wisconsin did on quality of life with dairy farms. And for improved environment, soil health, clean water, and clean air. And last but not least is improved health. And we'll go through each one of these. First of all, I want to talk about financial performance. And these are provided, we'll start with the dairy, because that's what I'm most familiar with. This is a study that was called the Dairy Grazing Farms Financial Survey. It was done at the University of Wisconsin by Tom Kriegel. Some of you might have heard of him. He's done a lot of conferences and given a lot of talks. But he studied over a number of years, from about 1999 to about 2010 or 2011 was his last year before he retired. And he found that the financial performance of the two dairy types differed significantly, but not changing over time. And so if you look at the bottom graph here, the brown line is for confinement dairies, and the upper line is for green line is for grazing dairies. He found on average over a 2-year period, and this was extended out for years as well, not just during this period, but on average, an extra $1.50 to $2 per hundredweight of milk equivalents. In other words, milk that was adjusted to the same fat and fat ratio overall. And because there's sometimes premiums paid for higher fat milk, but he adjusted it to the same fat ratio. Overall, the grazing farms, this included organic as well as conventional grazing farms. Overall, their net farm income per operations, and that's the income that goes directly for household expenses, was at least $1.50 to $2 per hundredweight more. So on a farm, dairy farm produces 1 million pounds of milk, maybe about 100 cows. That would equate to about a $15,000 to $20,000 net farm income for the household on that farm. And that was consistent over all the years. The organic farmers, of course, with their premiums, even made more. So let's look at different livestock enterprises comparisons. This was done by Ohio State, where they looked at stocking rates for a cow-calf, low intensity, all the way to sheep, high intensity. And the assumptions was that on the cow-calf, they would produce a 500-pound calf. And if they had a low-intense grazing system, they'd have a 100-pound calf per acre. 500-pound calves off 5 acres, or 100 pounds of calf per acre. And their net was $60. That goes all the way down to when you start looking at some of the more intensive work. You go to $150 an acre for a calf on a cow-calf operation. You go to stocker calves that are intensives, in other words, 2 stockers per acre, with a 540-pound gain per acre. In other words, a 270-pound gain over the season, which is not quite 2 pounds a day, divided by 0.5 acres is 540 pounds, $1.89 per acre, $189 per acre. And then you go into sheep. Sheep tend to be more profitable animals because they're smaller and they turn over faster in their growth periods, all the way to $208 per acre. So there's quite a variation in cost, enterprise comparisons. Let's look at a little simple enterprise budget to see what actually you can do to figure out your net return. Of course, your gross return minus variable cost and overhead cost is your net farm return. These are some of the figures that were given to me by Paul Dittman at Compeer Financial, which used to be called Badgerland Financial. And he breaks out the cost between variable cost and overhead cost. Everybody knows that variable costs are farm production costs that do not include your capital, such as your property or your buildings or your infrastructure. Variable cost includes cost to feed your livestock, seed, feed, fertilizer, and the overhead costs or anything on the farm as that whether or not anything is being produced. So your land, your buildings, any of that. So let's look at a conventional corn budget enterprise. This is back in 2016 using $3.40 a bushel. And I know that the cost of corn, the price of corn was about $5.60 on Friday. So things are very different now. But if you look at this enterprise budget at $3.40, they were losing $107 an acre for corn at 170 bushels a day. But if you look at the break-even price is $4. Okay, so we're at $5 a bushel, and maybe the December price, the futures price is looking at $5.50. So maybe you're up to $200, $300 an acre profit at the current corn price. But when that corn price goes down, you might want to have some livestock to improve your profitability. We'll see some other livestock costs here coming up. But with enterprise budgeting, you have to get at your variable costs. And in pasture, this is not necessarily always easy. You have to take your costs of establishing the pasture, your fence, your pasture establishments, your interior fencing, your water system, all that into, and you have to amortize that over the number of years of the life of those investments. So for example, if you're going to take a 40-acre piece of pasture and develop it, a 40-acre piece of crop field, convert it to pasture, you have to put a perimeter fence in, you have to establish the forages, you need an energizer, you need interior fencing, a watering system, and machinery and vehicles, maybe a four-wheeler to do that. And if you look at a typical 40-acre pasture, you look at putting fence around, a mile of fencing around the perimeter at $9,600. Divided by 20 years, it gives you $12 an acre per year. So these are all the establishment costs. A pasture establishment of $1,800. So basically, they're looking at $1,800 for the seed over 40 acres, where 5 years is $9 an acre. So the total economic cost of that pasture is about $28 per year per acre. So if you add those prices in to your economic depreciation, in other words, of your investment in establishing that pasture, plus all the variables you need per year, it looks a lot better than buying forage. And what this does is it compares it to buying 3 tons of forage per acre at $120 a ton. Well, that's a little low right now. The prices of quality hay in Wisconsin is around anywhere from 150 to 170 a ton. So it'd be even more expensive. So if you take the cost of the pasture, you're saving about you're saving about $100 versus the cost of $100 per acre or more versus the cost of feeding hay. So why would you feed hay if you have pasture available? The pasture forage is much cheaper to produce. Here's a grass finished steer budget. So if you sell your steer at about $3 a hanging weight, which is low for the market right now for grass finished beef, but let's just use that figure. And we use all the cost of buying an 800 pounder that we're going to finish off to around 1,200 pounds. We're going to buy that steer. We're going to have all the cost of grazing that animal. We're going to come down to about a return of about $257 per head or $171 per acre, which, depending upon the corn price, can be better than corn or less than corn, depending on the corn price. But it just gives you an idea with proper marketing. This is not a conventional market. This is a quality market, what you can do per acre financially on a grass finished steer. Let's look at some of the satisfaction with life. Now, what we did is we did a sociological study in Wisconsin with dairy farmers. We looked at different types of farm management, from large confinement to small confinement, to those that produce most of their forages, most of their feed from managed grazing, and those that had non-intensive pasture, had a dairy farm, fed mostly stored forages, but with some non-intensive pasture. And you can see the score averaged, the highest score was a 7. The two highest were the managed grazing and the large confinement. So it shows that those that are large farms with large confinements, with lots of help, lots of staff, people working for them and them managing, had a higher quality of life, as well as the managed grazing had high quality of life. The small confinement farms that were struggling, having to keep up equipment and struggling with prices of milk, and the non-intensive pasture farms had lower overall qualities of life. So let's talk about the environmental aspects of managed grazing now. Okay, so we still have soil erosion in Wisconsin. We haven't solved that one yet, and I'm sure that the same is true for Minnesota and Iowa, and Wisconsin, and Illinois. I'm sorry, but our water erosion on cropland averages still 3 tons per year annually. Our sedimentation also occurs, so that's just sheet and rill. If you look at this kind of sedimentation that occurs after a heavy rain, lots of tillage on the ground, we're still going to have soil erosion. Now, with a managed grazing, with a healthy pasture, with a canopy of sod and a thick, deep root system, we're able to hold on to that soil and hold it in place. So let's look at some examples of soil loss on a farm that, one of our discovery farms, where they were using different kind of rotations on the farm with crops, and comparing that to grazing systems. You start off with a corn grain oats, a corn grain soybean no-till, corn silage, alfalfa rotation, and you can see the average soil loss per acre per year. Just about everything except for the corn grain, corn silage no-till is over 1 ton soil loss per acre per year. The managed grazing is less than 1 ton. So you can see the differences. I'm sure this makes sense to everybody, knowing it perennial permanent ground cover on the ground is going to reduce your soil loss dramatically. Just to give you an example, we had a grazing lands initiative in Wisconsin for many years, and we were able to convert 120,000 acres from cropland to pasture just by improving 100,000 acres of pasture. We were able to take the tons of soil saved on each acre of about 2 tons, going from a 3-ton average to a less than 1 ton. We were able to save 240,000 tons of soil, or 10,620 truckloads of topsoil. So to put that in perspective, that's about, if you look at the sediment delivery to the ditches, that's about 2,100 truckloads of sediment out of our Wisconsin waterways. That's a lot of sediment. Let's look at things like impact on surface runoff. And this was a study done in Conshohocken, Ohio, on 2 watershed hillsides that were exactly identical, where they had runoff equipment and monitoring equipment, looked at summer grazing and winter grazing and runoff of nitrogen. So here on the left, you can see their winter grazing operation in the spring after they were done with their winter grazing, and on the right is no winter grazing, but summer grazing. What they found was nitrogen and phosphorus concentrations in surface runoff from the pastures were well below the EPA limits, but that the nitrogen averaged 3 to 4 parts per million on the winter, whereas in the summer it was less than 1 part per million. On the winter paddocks, we basically had some nitrogen runoff due to just basically the management of the runoff, our management of the animals, and there weren't buffer strips, so as you would know, you'd have more runoff there. Here, this picture is 1,000 words. You can see where this happened in Iowa County, Wisconsin, near Dodgeville, where we have the picture on the left comes out of this so happens that it was done in the spring, about March, right after some March rains, runoff periods. The producer took this picture, and you can see where the cropland watershed is coming in and the pastured watershed on the right side. To me, that tells the whole story. What about groundwater? We have a University of Stevens Point, University of Wisconsin Stevens Point, that has a pretty renowned groundwater lab up here in Wisconsin. They did a 3-year study on nitrogen leaching in groundwater on rotationally grazed farms. They were dairy farms. They were pretty intensively managed with probably daily moves. They found that there was some significant nitrogen leaching under urine spots, but when they looked at the mass transport and the concentration in the groundwater overall over the whole field, they found that the mass transport was much less than potato farms or corn farms. And one of the things they found was that if they had high concentrations underneath the manure patties, they found that there was a faster denitrification occurring due to the higher organic matter in the soils. So they also found that under the grass legume pastures, they were always below the 10 parts per million, but they did find higher levels under the paddies. But we found out that overall, because of the higher organic matter in the soils, the mass flow in the groundwater overall was much lower. And it has to do with this nitrogen denitrification occurring rapidly due to those high groundwater soils. One thing they did find was that nitrogen application, if it should be done in pastures, should be done over split applications. in May and August, because if you do it during the period when the grass is not growing rapidly, you're going to have quite a bit of leaching, more than you would if you did it early in the spring or in August when the grasses are growing rapidly, and towards the end of August, beginning of the September period when fall is coming. What about riparian areas? We have a lot of trout streams, Southwest Wisconsin, where this picture was taken. The one thing they are concerned with is fishing access to those trout streams, and then stream bank stability. We built a lot of riprap up here, because of the fact that some of the streams are very unstable. And we looked at our ecosystem study, looked at the stream bank stability with grazing versus no grazing, and the fisheries on streams. So there were 4 treatments. They had grassy buffers along streams. This all occurred in Southwest Wisconsin in the driftless zone. They had streams that had managed grazing, with other words, rest rotation grazing systems along them. They had streams with unrestricted stream access, and then streams with woody buffers. Just curious, what would you think? How would the woody buffers and the grassy buffers compare to the grazing? Well, it depends on what we're talking about. They measured bank erosion and how much bank erosion was occurring. They found that unrestricted grazing had significantly more bank erosion than the managed grazing or grassy buffers, as you would expect. But the woody buffer was a little bit even yet higher than the grassy buffers. Why is that? Why that is they surmised that because under the woody buffers there was less vegetation on the ground, less ground cover. There was more apt to be water coming in and eating away at the banks, and then the tree would fall into the stream. And once the tree fall into the stream, you'd have more water going around the roots, around the bottom of the tree, and creating more bank erosion. The other thing they looked at was aquatic habitat index. So aquatic habitat is a combination of looking at the kind of invertebrates in the stream, health of the stream towards wildlife fishing. And they also looked at the invertebrates on the banks above. So they put this all together into an index. And again, the managed grazing and the grassy buffers came out pretty close to the same, whereas the unrestricted grazing and the woody buffers had lower aquatic habitat indexes. So in conclusion, in this study, they found that the riparian study with the rotational grazing versus the grassy buffers versus the wood buffers, basically were the grassy buffers and managed grazing were similar in fish habitat, while managed grazing with a short occupancy period protected erosion and had the best diversity of plants. So when it came to what kind of fish were in the stream, it didn't really matter whether they had a buffer or not or grazing, but it did matter when, as far as protected the ground, the bank was protected from erosion, or the diversity of plants and wildlife along the banks was better with the grazing. So what does that mean for grazing stream bank areas? Well, we can provide good protective cover for the streams if we graze them properly, leaving plenty of residual, move animals in and out very fast, and we minimize the impact on bank erosion by building crossings. So we try to build our crossings every 1,000 feet or more along a stream pasture, and we try to do short occupancy periods and quick moves, so we can maintain that grass cover and have open streams for the fishermen to go in there, and also good forage vegetation for the cattle or the livestock. Grassland birds are very important, especially those birds that are tend to be more in the endangered list. The number of grassland birds overall nationally has gone down in the last 30 or 40 years. So they're concerned about protecting them. Um, there's all kinds of grassland birds depending upon the structure of the grasses. The taller grasses really favor some birds, and the shorter grasses favored others. So if you look at the kind of species um, that favor the the higher cover, they're going to be probably rarer species, Henslow sparrow, sedge wren, that need high covers of probably greater than a foot or more of vegetation over the year. Whereas those that are in the moderate and those that work well with the rest rotation system, like the eastern meadowlark, the bobolinks. So by improving the grass nesting cover, you're going to improve the number of grassland birds there. So in a general rule of thumb, 4 to 5 inches of residual is important for their nesting, and moving cattle through paddocks quickly in the nesting season minimizes the nest trampling. Later on in late summer, you can take more forage, but during the nesting period, you need to leave higher levels of residual. So it's important that we have our grasslands that are well managed um, for grassland health, or grassland bird health, excuse me. Okay, what about the increased soil carbon reserves and improved soil health? Well, we know that a 30-year integrated cropping trials at University of Wisconsin, we found that all the cropping rotations of all 12 of them that range from simple corn and soybean rotation with tillage all the way down to a long-term hay rotation with corn. Um, the managed grazing has the highest total possible carbon gain in the top 8 inches of soil. Of all the cropping rotations, only the managed grazing has a total carbon gain. All the other rotations are losing carbon in the top 8 inches of soil. And that's because 90% of the organic matter exists in the roots in grassland soils. And that as the roots get bigger and as the plant becomes longer lived in the soil and there's more extensive root systems, you increase the organic matter in those soils. So as you leave more residual and you have more stronger root systems, because plants make carbohydrate, they have to provide their root systems and feed their root systems. So the more leaf area you leave, the more root systems you have, the more organic matter you're going to have in the soil. So over 20 years, researchers have seen an average in soil carbon content of 1% or 2% organic matter on soils. This equates to 20 tons of soil carbon per acre. A 1% increase in soil carbon increases the water holding capacity of the soil by about 24,000 gallons of water. That makes a large difference in a drought year if you have good soils. If you have good pastures with lots of soil carbon. So we all know that soil health is is on the mind of a lot of people now. It's a big issue in our agriculture. So we need plant diversity, which pastures can provide. We need to disturb them less. So we're not going to be disturbing if we have perennial vegetation there, keep plants growing throughout the year and keep our soil covered. So here's an example with disturbance, very short period of disturbance, putting fertilizer down, putting manures down, getting in, getting out, crushing the residual into the ground too, and putting more organic carbon into the soil so that we have that granular structural function caused by the roots. There's good aeration in the soil. It makes for good soil health. Just an example, this is in South Dakota. One of my colleagues, when I was working for NRCS, gave me this slide. On the left is a continuous grazing, seasonal grazing set stocking system. And on the right is a rotational grazing. If you look at the profiles of these soils, you can see the dark, high organic matter soil from the rotational grazing system. Even though there's a good topsoil layer and there's some good organic soils on the continuous, these are on both sides of the fence here in the same general area. You can see that the organic soil is less because of the lighter color in the soil. And also the infiltration graph on the right, due to the rotation versus continuous grazing, the infiltration rate in inches per hour is much higher in the rotational grazing. So a dense sod minimizes erosion and runoff. Groundwater is filtered with dense roots and loses nitrogen to the air to protect the groundwater. And stream banks are protected from erosion. Grassland birds habitat is improved. And we have a large carbon sink created. So what about livestock health? What can we say about livestock health? Many of the dairy farmers that I've worked with that have put animals out on pasture for the first time find that their biggest improvement in profit comes from animal health improvements. Decreased foot and leg problems are specifically the first thing they notice. Getting them off on concrete in a confined system out onto the pasture, onto the soil, really helps their foot and leg problems. They have a lot lower incidence of respiratory diseases, especially if they're doing some out wintering or bale grazing outside and don't have them cooped up in a closed barn during the winter. Calving problems too. You have fewer calving problems. The animals are more, they just healthier. They just have a lot more physical capacity when they're out there walking on the grasses, walking on the ground. Also, they have a greater life longevity. So we have improved livestock health. So what is the characteristics of successful operations and that we would want to encourage to do managed grazing? If we are going to have a successful operation, we have to strive for improvement of all the resources on that farm, including land, livestock, people. It could even improve our wildlife and other resources. We also have to have good analysis and make good decision making. We have to have good decision making tools. So in a grazing system, that's where management intensive grazing, with the emphasis on the management, comes in, where you have to know, according to the weather, where you're going to be going with your animals next. Should you be moving now or later? How do you do all the art of managing those paddocks to move animals through? You need to know how much forage you have available. The other thing we need to do in a successful operation is wage war on cost. We know that for every dollar we put in inputs, we have to get $1 out of it in order to do it. So spending money without a production or having something to justify it on the other end does not make sense. So not only do we have to wage war on cost, but we have to optimize production for every amount of new cost we add. We also have to place an emphasis on marketing. If we're going to get the value we need for our product, we have to emphasize how to market. And if we're doing something that's good for the environment and good for the nutrition of the food, we need to be getting a good market for it and getting a good price for our product. So that ends the first session